Okay, video lesson 3.4, composition of trig values. If this word composition looks familiar, it should, because in Algebra 2 you did f of g of x. And this is where you're taking a function and the input is not a number or x, but it's another function. And so that's what we have here. And there's going to be two different types. I'll explain that more as the lesson goes on. But let's read the directions, make sure we understand what we're doing. Find the exact value of the expression using radicals or radians if necessary. Okay, so let's look at number 1. It says we're going to take secant of arcsine of 5/7. Now, we're always going to work from the inside out. Okay, so let's think about what this is asking us. On the inside, it's asking us to take arcsine of 5/7. It's giving us a ratio. It's asking us to find the angle, and we're going to do that in radians. Now, if we're not able to find the angle, then we're going to at least find out enough information about that angle so that I can then take secant. And that's actually what we have to do here, because, excuse me, we don't have a special right triangle with 5 and 7. So let's go ahead and draw a triangle, though. And I don't really know which quadrant I'm in. 5/7 is positive, so I could actually assume that I'm in quadrant 1. And when we're thinking about this, you know, put your theta in your reference angle. And so opposite would be 5. Hypotenuse would be 7. And then you would do Pythagorean theorem to find the missing side. Okay, so that would be root 24, or 2 root 6. I'm not going to spend a lot of time on that in this lesson. Okay, and again, we can assume that we're in quadrant 1. So I could have actually drawn this triangle in quadrant 1, or you could just draw a picture like this. This will help you see. And the reason it's important we know what quadrant we're in is because when I take secant of this angle now, I'm going to switch colors here to show the two different steps. When I take secant of this theta, okay, I need to know whether my answer is going to be positive or negative. And since I'm in quadrant 1 where everything's positive, my answer is going to be positive. And I remember that secant is the reciprocal of cosine. So instead of a over h, I would have h over a. So 7 over 2 root 6. And this is my answer. Now I need to simplify. So root 6 over root 6 would give me an answer of 7 root 6 over 2 times just 6, which is 12. And if 7 and 12 simplified further, we would, but it doesn't. Okay, and I want you to notice that I started with a ratio and I ended with a ratio. I never actually figured out what my theta was, but I found out enough information about it, meaning the triangle and what quadrant I'm in, so that I could then do something with that theta. Okay, but I want you to notice that what I started off with was a ratio, and after 2 steps I ended with a ratio, and we're going to see this pattern. Okay, we actually already did this. If it looks familiar, it should. You could also do this in your calculator, but since it wanted exact, that's why we're doing everything by hand, so that we don't round. Okay, so let's look at the next one. Again, they're giving us a ratio, and we need to either find theta or find enough information out about theta. Okay, now let's think about what this means. Okay, I'm going to go ahead and draw the triangle. Here's my theta, and the hypotenuse would be 3, and the adjacent would be 2, and this is not a 30, 60, 90 triangle, actually. It's not root 3 and 2, and they would be in the wrong place anyway. But when you do Pythagorean theorem, you get the missing side to be root 5. Again, not going to spend a lot of time on that. And we need to identify what quadrant we're in. Okay, so it looks like I'm taking arc secant of a negative. Now, arc secant's restricted range, remember this from principal value, 3.2. Arc secant has the restricted range from 0 to 180 or 0 to pi. If the ratio is positive, we stay in quadrant 1, like what happened in example number 1. But since this is negative 3/2, our principal value places us in quadrant 2. All right, now this is important because when I go to the second part, which is taking cotangent of my theta, Okay, not only do I need to look up my new ratio, I need to think, is cotangent in quadrant 2, is it positive or negative? It's negative. Okay, quadrant 2, cotangent gives me negative answer. Okay, now let's think about TOA. Tangent would be opposite over adjacent, but cotangent would be adjacent over opposite. So 2 over root 5, and this simplifies to negative 2 root 5 over 5. And there's my answer. Again, we started with a ratio. I ended with a ratio. Do you think that if we start with a negative ratio, we will always end with a negative ratio? It is likely, but not for sure. The reason is because if I think about that, I put myself in the second quadrant. What if I was taking sine out here? If I was taking sine instead of cotangent, my answer actually would have been positive because in the second quadrant, sine's positive. So don't just always just let the negative follow through. You really do need to look and make sure you're in the correct quadrant for negative. Okay, so let's look at number 3. Okay, again, I'm starting with a ratio, and I'm taking arctangent of a ratio to find a theta, or at least enough information out about a theta. Okay, so let's put our theta right there, and so this would be OA, so opposite would be 5, adjacent would be 1. We're going to do Pythagorean theorem and get the hypotenuse to be root 26. Okay, again, I need to know what quadrant I'm in. So it looks like tangent, arctan of a negative, that uses restricted range negative 90 to 90. If the ratio had been positive, I would have stayed in quadrant 1 and not have messed with this. But since the ratio was negative, that puts us in quadrant 3. Okay, so when I go to the second part of this problem, I got to make sure I know, hey, I'm in quadrant, I'm sorry, not quadrant 3. What quadrant are we in? That's right, quadrant 4. Okay, so when I do the next part, cosecant of theta. Okay, cosecant is the reciprocal of sine. Sine would be 5 over root 26. So my answer is going to be root 26 over 5. And in quadrant 4, cosecant is negative. So I'll put a little negative there. And I don't even have to simplify any further on this problem. Okay, example 4 shakes things up for actually a couple different reasons. But what I want you to notice, 1, 2, and 3 all had the arctangent with the ratio on the inside, which was representative of a theta, an angle. And then we took another trig function of that angle. On number 4, they're putting an angle right here. You have to take the exact value of that angle, and then you have to do arc trig of that ratio. So it's kind of backwards from what we've been doing. And there's another reason this is going to be shaken up, and I'll explain that as we go along. So first what we need to do is we need to find out, well, okay, well, what is sine of negative pi over 6? Okay, well, this is exact values. If you're thinking you don't know how to do this, you do. This is from Unit 1. It's from early on in Unit 1. And so this is 30 degrees, okay, 30-degree reference angle. And so, excuse me, this is in quadrant 4. It's a 30-degree reference angle. It's in quadrant 4. Okay, so sine of 30 is 1/2. And in the fourth quadrant, sine is negative. So sine of negative pi over 6 is negative 1/2. All right, and the next part of this is to find secant of that ratio. Or arcsecant, excuse me. All right, now this is like principal value. Okay, when you have just the trig function of an angle, you are doing exact values, what we did in Unit 1. When you're doing arc trig or inverse trig of a ratio, this is principal value. Okay, so this is like 3.2. So what is arcsecant of negative 1/2? Before, if you're calling out an angle, if you think you know what the angle is, I want you to remember that secant is hypotenuse over, excuse me, adjacent. Could the hypotenuse be 1 and the adjacent be 2? No. So at this point, this is one. We saw that we had some like this. This is one that would be no solution at this point. Okay? Now, just to kind of keep things moving, let's assume we had a different problem. And let's say instead of arc secant, let's say it was arc cosine, because this is going to be possible. So let's say we had arc cosine of sine of negative pi over 6. Okay? Well, you'd start it off the same way. Okay, you'd figure out what was in here. Now, it'd be the exact same ratio as before, so let's go ahead and write that. Arc cosine of negative 1/2. Okay, and this is possible. Okay, the reference angle here would be 60 degrees, or a pi over 3. Okay, and your restricted range would put you here. Okay, so a 60-degree reference angle, negative ratio puts you in quadrant 2. Okay, so our final answer here, principal value of arc cosine of negative 1/2, would be 2 pi over 3. Okay, so I want you to notice a couple of things. You start off, let me use a different color here. You start off with an angle. You take a trig function of that angle, and you get a ratio. And then you take an inverse trig function of that ratio, and you get another angle. So just like how before, on 1, 2, and 3, you started off with a ratio on the very inner part of the composition trig function. You ended up with another ratio. These problems, you start off with an angle, and you end up with an angle. And they don't have to be in the same quadrant. They don't even have to be the same reference angle. Okay, you just work through the problem, doing each step using the knowledge that you already have. Okay, so let's try another one. Okay, number 5. So number 5, we got to think about what type of problem this is. All right, so it looks like we're starting off with an angle, and I'm asked to do an exact value of that angle. And when you do this, you need to think, okay, what is the reference angle and what quadrant are we in? It looks like we're in the 3rd quadrant. Okay, so sine of 60 is square root of 3 over 2, and in the 3rd quadrant, negative. All right, now I go to the outer part. Now I'm going to take arc sine of this ratio. This is, now we're doing a principal value. What is arc sine of negative root 3 over 2? I'm going to give you a couple seconds to try to finish it on your own. So again, it's a 60-degree reference angle. But due to restricted range, okay, we'd actually go to quadrant 4. And remember, we take the shortcut back. So this would be negative pi over 3. Now, something interesting to note here. Don't want to skip over this. Arc sine and sine, it didn't undo each other. Meaning, when you take arc sine of something, you didn't end up with that exact thing. You did end up with an angle, all right, but it actually put it in a different quadrant, and that's okay. There's a little note at the bottom of your notes. It says arc sine of sine of x equals x only if x is in the range of the inverse sine. So 4 pi over 3 was actually outside of the restricted range, so that's why it didn't end up that way. And the same is true for the other inverse trig functions. All right. But again, really want to point this out. You start with an angle on these, you end with an angle. And that's something that will help you keep things straight here. Okay, let's look at number 6, last problem. This time I'm starting with a ratio. So what will my final answer look like? A ratio. Okay, so let's take arc cosecant of this ratio. And again, if you could find the angle using whatever method you would want to, but this is not part of any special right triangle. So the only thing I can do on this one is to draw a triangle, mark my theta. The hypotenuse here would be square root of 5, and the opposite would be 2. Then you would use Pythagorean theorem to find the missing side, which in this case is just 1. You also need to make sure you know what quadrant you're in. Using principal value, even though I can't actually find theta, I still need to know what quadrant I'm in. Okay, so for arc sine and arc cosecant, if the ratio is positive, I get to stay in quadrant 1. But since the ratio is negative, I need to move to quadrant 4. Okay, so then when I move to the second part, recognize you're in quadrant 4 now. Secant of this theta, okay, secant would be in quadrant 4, positive or negative? Positive. Okay, so this is a case where you end up in a different quadrant, but actually cosine and secant are both positive in quadrant 4. Okay, so my answer here, my final answer is going to be positive. It's going to be positive root 5 over 1 because of the ratio. And then I'm just going to go ahead and write that as just root 5. Okay, all of these you can check on the calculator. You still need to be aware that if you take arc cotangent of a negative, your calculator doesn't understand how to do that because you would be typing in arctan, and it would use arctan's restricted range. So, but all the other ones of these, you should be able to type them in your calculator, and you'll get a decimal answer, like for root 5 or negative pi over 3, but you can easily just type in the answer and see if you get the same decimal. So it's pretty easy to check your work, and that's it.